Everybody to our 172nd Reading Online Sports Economics Seminar. It's good to see lots of people here, and it's very good for our first seminar of the autumn. It certainly felt very autumnal here in the UK last few days, but our first speaker is Georgy Shukaylo from the University of Michigan, presenting skis, poles and rifles, evidence of rational belief updating from professional biathlon. I should say, as we get going, it's always good to acknowledge we have generous sponsorship in the Roses series of the Sports Economics Review, a new journal in the area of sports economics. And if you're relatively new to this and you've forgotten how online seminars go, please do keep your microphone muted at all times. I haven't checked, Georgy, are you happy to take questions as you go along, or would you prefer to park them all for Q&A at the end?
If it's absolutely necessary, and like for instance, some folks might be leaving before the end, then sure, interject. But I would love to please for everyone to save questions till the end.
Sure, that sounds good. So only absolutely essential clarification questions during the talk, and there's plenty of time for Q&A. Georgy, you've got the best part of an hour to talk in, and so without any further ado, given there are some pressing schedules, Georgy, please do take away your talk.
Okay. Do we please verify that we see my screen, James? Just
Yep.
Give me a thumbs up. Okay,
Got
perfect.
Yep.
Wonderful. So thank you all very much for being here. It's an honor for me to be presenting. And again, thank you to Sports Economics Review for hosting the seminar, and James for all your hard work in organizing the schedule. So today, even though it is early to mid-September and the weather is still quite warm, I'll be talking to you about a winter sport called biathlon. So first of all, biathlon, as it is shown, is one of the most popular winter sports for European spectators all around. And why is it so? It's because, unlike cross-country skiing, it provides a surprise element in up to 4 shooting range appearances per each race. It varies, it's either 2 or 4. In relay races, it's 8. Per team. So for the most part in North America, biathlon is called to be off the radar. And there are, this is the Athletic article that is basically saying that, it's not developing in the same pace it is in Europe. And most biathletes, I have to preface, they do come from European countries as well as North America. There are some in Asia, but, mostly Northern Hemisphere, far from the equator type countries. So there has been a development that the International Biathlon Union, IBU, I'm going to refer to them as IBU for the rest of the presentation. They have been increasing compensations for biathletes since the 2011-12 season, both in magnitude, so people are getting more euros, and then the number of places that are being paid for race. So we're going to retouch on that as we go along. So this is the prototype of biathlon exactly 100 years ago in 1924. It was a sport at the 1924 Chamonix Olympics. And then later in 1928 all the way to 1936, it was a showcase sport. After the war, after World War II, there was a big commitment by the Modern Pentathlon Association to separate biathlon from military drills, because the prototype of biathlon it's literally coming from the army. So there were 4 team members. One of them was a captain, as we see pictured here. I'm not sure why there are 5. Maybe one of is a reserve biathlete. But these military men would cross-country ski to the top of some hill, do the shooting drill at a real target, at a practice target, and then descend down. And the time they've done it on, they were judged on, and they had to carry around 24 kilos of ammunition, which is roughly, for my North American friends, roughly 53 pounds. So, it hasn't been well established in the Olympic realm until the first modern format of IBU World Cup started in the 1990s. So this is biathlon in 2024, which is, does not bear much resemblance to what we've seen in the last picture. This is, I think, taken during mass starts, so it might give you a false impression that in all biathlon races, everyone starts at the same time. But again, we're going to touch up on that. But here we can see aerodynamic suits, and instead of carrying 24 kilos or 53 pounds of ammunition, now there are 3 to 4 kilo rifles that biathletes are carrying on their bags, on their backs, and everything is very technological. They have goggles, they have every little thing that would help them. They can basically find sponsors for ski equipment. So it's pretty much a semi-professional sport, and I'll touch on why it's not fully a professional sport yet and what limitations it may have. So in terms of behavioral economics works, and where sports touch to it. So just some of the concepts that biathlon can help us get a better elaboration on is, well, first of all, there's an immense pressure under which decisions are made during biathlon races. There's high intensity skiing in individual races. For men, it's 20 kilometers. For women, it's 15 kilometers. So there's a big cognitive overload for athletes in biathlon than in most other sports. Also, the goal gradient hypothesis. We've seen several papers calling for the resurrection of the goal gradient hypothesis. So, effort allocation among biathletes at different parts of the race might be different, and certainly they will ski faster towards the finish, and we'll see a lot of that in this work. Also, reference and belief updating, something that I'll be looking at today. So the strategies are based on reference point benchmarks, and we're going to see, whether the domain of gains or the domain of losses alone can explain the variation in skiing. And then also loss aversion. Now there's shot-by-shot data that is becoming available. So researchers can look at sort of these microscopic risk-taking behaviors at shooting ranges, especially considering that there are harsh consequences of missing. So first, let's revisit some articles that basically all make claims, among others, and there have been plenty. But something that recently came out in the Frontiers of Behavioral Economics is that article by Dietl and some co-authors that basically use the NBA to increase the understanding of how frictionless markets work, and revisit the Coase theorem with the help of, how are free agents in the NBA different in their labor market behavior from the NBA athletes who get traded directly from team A to team B. So prior to that, there has been a wave of COVID studies, and I know this is a debated topic, and some folks in the audience have even written about this. So I'm just going to cite one article here that during COVID in European football, there has been evidence that home advantage effect disappears, and I know this is still not outlined because there are some other papers that say that it has not disappeared, that even a small crowd might be beneficial for the home side in European football. However, I'm just citing one of the papers to show that COVID has been seen as the large natural experiment, and it has touched all areas of economics, including, of course, sports economics. And then there was a 2010 paper on the first mover advantage in penalty shootouts studied by Epesteguía and Palacios Huerta. And that work is basically showing that the first mover advantage holds up in penalty shootout games, that teams who start or win the coin toss and start shooting first, they tend to win more shootouts than the second mover. So all of these phenomena are explained with sports data in behavioral economics. So now, what does exactly biathlon data help us explain? And what has been some prior research. So Harb Wu and Alex Krumer in 2019 basically say that in front of home audience, there's the choking under pressure effect due to the fact that perhaps biathletes feel, a little more worried performing in front of home audiences, and they tend not to perform as well in shooting in sprint races. So Lindner also finds that leaders will choke under pressure in this, again, microscopic specification, where the fifth of 5 shots, and every shooting range there are 5 shots in biathlon, the fifth out of 5 shots is usually missed by leaders type races. Also, another article by Alex Rumer in 2023 in ESMQ finds that in mass start races, if biathletes start lagging far behind after the initial stages of the race are done with, because the way the biathlon competitions are organized, and they're usually in these sort of stages or sets, meaning there are several different types of races, one after another, often being a few days in between. If there's already nothing to gain from going faster, there's an effort reduction in biathletes who lag behind, and they try to preserve energy. And then Björklund and the co-authors tried to balance between the time spent at shooting ranges, skiing speed, number of missed targets, and to basically the determining of the different success categories by strata of biathletes. So they sort of paved the way to stratification by by different strengths of biathletes, because I'll come to why it is important. But before that, something I'm going to be heavily referencing today is the reference point and belief updating. So all of those concepts come from the 1979 work by Kahneman and Tversky on prospect theory, and it seems to be the honorary citation every time anything on behavioral economics is done. So I'm going to cite some of the papers that have looked at some of the more successful papers that have looked at the applications of prospect theory in sports. So Pope and Schweitzer, in their Is Tiger Woods Loss-Averse paper in 2011, basically find that golfers putt more accurately for pars than for birdies, all things considered. That when they are operating in the domain to save a par, they would putt more accurately than they would be in the domain of gains to putt for birdie or better. Doman in 2008 also offers insight into how football referees are subject to social pressure, and they behave differently and add more stoppage time when they see that home teams are slightly behind. So the rationale there would be that they would face a lot of criticism for not adding that on the home side. They're at the home stadium, so that is sort of loss aversion, if you will. And then another paper, so Devin Pope comes in again, another co-author. So Berger and Pope in 2011 also, they give way to a series of papers looking at halftime or timeouts being the reference point. And they actually find that in both amateur basketball, so the NCAA level, and the NBA level, teams that are slightly behind at halftime have a higher than 50% chance of probability of winning. Simply because, at halftime, there's a way to do the reference point. If they're slightly behind, maybe the coach breaks a couple of boards in the locker room and, really motivates the team. Whereas if you're, slightly in front, there might be a degree of satisficing with the current result. So where can this literature go next? We all love to think that, it's still very under-researched and there are a lot more things to be done. Because we love to think that it's the result of natural experiments, and it purely is. So a lot of individual sports can be boiled down to just one objective, and we've seen many of them at the Summer Olympics, like javelin throw, shot put, skeet shooting, or even car racing and braking that made a very short appearance at the Olympics and is no longer included in the Olympics program. But we've all seen that, essentially it's, do you dance better than your opponent? Do you throw the javelin further than your opponent? However, we still need to see, well, what if there are some ongoing sub-objectives in biathlon? Because biathlon consists, of course, of skiing and shooting. That's the exact translation of the Norwegian term for biathlon is ski shooting. So that where its roots are in Scandinavia, it's still, being known for the two sub-objectives that it has. So my research questions and hypotheses. Well, first of all, to what extent do missed shots in individual races in professional biathlon affect subsequent skiing performance? And how does this impact vary across different laps of the race? So I hypothesize that, missed shots in individual races will be significantly negatively affecting subsequent skiing performance, with the magnitude of the impact decreasing in the later laps of the race. Meaning, if there is still stuff to salvage after a poor shooting performance, a biathlete will ski faster at earlier laps than as opposed to later laps. The second hypothesis is based on the accumulation effect. So how do accumulated missed shots in biathlon affect skiing performance over the course of an individual race? And does this impact vary across different laps also? So I think that, as the race progresses and more missed shots are accumulated, meaning more penalty time is accumulated, biathletes start skiing faster, but in the later races, stabilize their effort in order to preserve their energy, because they know that they cannot salvage the race and cannot win a monetary prize or place in Nations Cup points, everything we're gonna dissect and talk about. And then the third one is basically looking at the binary effect. So is it the intensity of missed shots that matters, or is it just the extensive margin of whether or not you had a miss at the shooting range would affect your skiing performance? And I would think that any missed shots will have the detriment on skiing performance. The extent of this penalty on skiing time will differ depending on the lap and potentially decrease over time. So this is my main model specification. So ski time is a function of ski time of biathlete I at shooting range at lap K in the respective race T would depend on the misses they have incurred in the last shooting range, plus whether or not the dummy for home athlete, maybe they're performing better the home crowd and they try to salvage their misses. So I want to account for that variation. The typical age and age square components to take away for any decay in sports performance, and then also their rank by cumulative time, meaning ski time plus any penalty time they might have accumulated in the previous lap. And then for the supplementary accumulation model, everything that changes is just the misses accumulated from the first to the most current shooting range, and there are only 4 in individual races. And then later on, it's the ski time of the indicator of misses from above 0, whether or not there is indeed a binary effect. So just quickly, if revisiting prospect theory, this is the chart of what Kahneman and Tversky basically came up with, that individuals, when reference point is at 0, would perceive gains much less util than they would losses. So in other words, this leads to the whole loss aversion theory that losing something is perceived more as more harshly in magnitude than winning something. And I would like to reiterate that just for this first specification, I will revisit the domain of gains, of course, but I'm assuming that anything below 0 is a loss. So while we will look at the descriptive statistics, there will be this assumption that any miss will land you a biathlete in operating in the domain of losses, meaning that with each individual miss, there's going to be less emphasis put on the miss, say going from 4th to 5th, than going from first to second, for instance. So the data is, I have data from WCHS, the World Championships of Biathlon, and IBU Cup level, which is the second tier of international biathlon competitions, Both are organized by IBU. Sometimes athletes would cross compete in them, in those, but World Championship events and IBU Cup stages are never at the same time. So that allows some biathletes that may want to participate in both to do so. But usually World Championships is the most elite level. They also have the World Cup that happens once every season under their name, and they also have the Olympic Games as part of going to the Nations Cup and Individual Cup points. So the data is retrieved from biathlonresults.com, the official data center website for the IBU. And again, it goes as far back as 2001-2 season, so that's how far it went. So why am I considering individual races only? You might be wondering, especially for those in the audience that have prior knowledge of the sport of biathlon. So individual races is the only format that would combine unobstructed start conditions, meaning those are interval starts. That decrease the chance of skiing incidents, someone stepping on someone's ski or breaking someone's pole, etc. And there's also the exogenous penalty treatment. So if you look at the table further down, a 150-meter penalty loop in all other traditional types of biathlon races would benefit faster and better equipped skiers. So for instance, if I come from a country that is known to be a biathlon powerhouse like Norway, I might have better ski managers that will treat my skis better with illegal Vaseline-like substance, and I will ski faster. Whereas if I'm a biathlete, say from Argentina, and I'm sponsoring myself and the federation is not giving me enough money, I cannot run that 150-meter penalty loop, all things being equal. If, for instance, at the same shooting we have one miss, the Norwegian athlete and the Argentine athlete, but however, a 1-minute penalty in individual races treats everyone the same. That is partially in place because frankly, it would make the race even more grueling. Like imagine as a female, you have to run 15 kilometers, as a male 20 kilometers, and on top of that, you are accumulating 150 meters for every miss. So if you miss all 20 shots, that would be 3 kilometers on top of what you already designed to run. So this has always been the case that time penalties have not been replaced by penalty loops in individual races, even though there have been attempts, but they haven't been successful. So in terms of the race progression, this is the little schematic that I have. So biathletes start, they ski for a lap, then they do the first shooting in prone position, so lying down, essentially looking forward, lying down on their stomach. Then they pick up the rifle, and with the rifle, they ski the second lap. They do the first shooting from the standing position, and then the cycle essentially repeats. So then there's the second prone, the second standing shootings, and then after the fourth shooting, they do the fifth lap, and then they essentially finish. So there are 5 about equal laps in this progression. So this is from Idre Fjäll in Sweden. This is one of the IBU Cup race schemes. So this brown course is being used for males. So it's the largest course distance that they have. So if you see down here in the middle, there's a start. And then the biathletes go along this route, they skate, and where it says biathlon, I'm not sure why it says biathlon as opposed to shooting range, but this is the shooting range where they all shoot, and then there's also some sort of a grandstand for spectators to observe the shooting. There are very few spectators along the route. This is where coaches will give that precious information out and encourage biathletes to ski faster or slower, depending on the competition, because they have data at each interval. And, biathletes hear that. So there's also the assumption of perfect information. And this, on the other hand, is the female racetrack. And you see the only difference here is that, it's cutting this extra loop out, so it comes down to 15 kilometers total over the course of 5 laps. So in terms of descriptive statistics at the race level, again, I have data on 23 seasons, and how it varies by females and males. It's repeated cross sections, basically within about 11 to 1200 female biathletes and about 1400 male biathletes. The number of nations slightly varies, so it is around 50 for two of the genders represented. There are 41 courses that have been used throughout these 268 races by females, and for males it's only 38. There's a slight difference in the number of host countries. There's 138 female races and 130 male races, so that data is about balanced. So there's about 60 to 65% of World Championship races as opposed to IBU Cup. And then there's a slight share of Olympic races. And if you're doing math in your head, the three shares will not add up to one. That's because, again, Olympic races are a part share of World Championships. So I just wanted to put it out there to see that indeed that is that big of a fraction. And these events do not happen too often. Around like 10 to 11 of them per year if you divide 268 by 23. So, and now looking at the descriptive statistics at the biathlete level, at each, we can see that, well, first of all, they shoot slightly worse from standing position all around because it's, much less stable. You don't have the ground to support your arm when you're lying down in prone position, for instance. And then we see that the age of participation is around is around 26 years, and however the median would be slightly smaller, meaning that the data is skewed to the right a bit. In terms of the ski time in minutes, we see that those align, but across both genders, they sort of start going down with each individual laps up to and including the fourth lap. And then if you look at lap time in minutes for lap 5, of course, there's no need to pace yourself. You're just trying to make it to the finish, and hence that will be slightly shorter, in terms of the time spent. So going back to the first model, there is indeed a statistically significant impact on skiing faster after each individual miss on skiing time. And again, these effects are in minutes. So altogether, they will not represent all that much. Like 0.1428 of a minute is around 10 seconds. So it's not that significant, but over the course of the race, it can accumulate to either win you the race or place you in that winning, prize eligible position or not. Home athlete status is pretty important, but again, not that much in magnitude. But indeed, if we look at the linear age relationship, it is significant. But and then everywhere else is basically giving us the good explanation of what happens in the between athlete variations. But it's these models are not as good for explaining what happens within these biathletes and why would they vary their skiing time across different races. So then, if we look at females only, there's nothing really new except for age is all of a sudden not a statistically significant factor for female skiing. However, age squared is, so there might be like a higher degree polynomial effect here in terms of skiing. Maybe there's there are just two vertices, two humps in terms of how the performance changes over the course of the career. And again, the R-square, the adjusted R-square remains pretty high, and within R-square pretty low, except for the fifth lap, meaning this model does not really explain the variation within athletes, but between athletes it does perfectly fine. And then the effects are, almost similar, almost the same for males in terms of their magnitude and significance. But again, the age factor comes back later on. And again, the R-square I think is even higher for males than for females. So then, just to revisit, it's the misaccumulation effect. So lap 2 disappears because the lap 2 coefficients would be the same as they would be for the first main model specification. And here we're seeing that accumulation effects matter, but they matter less in terms of time added, time subtracted from skiing, or faster effort exerted, when the further down into the race we go. So as of lap 3, after 2 shootings, if there's still the time to salvage the race, then biathletes would, essentially try harder. The home athlete dummy, remains significant, as is everything else. But then again, for females only, it sort of disappears, meaning we can say that misaccumulation effect would not really matter to home athletes. They would still go with their pre-race strategy. However, for males, it matters, ever so slightly, and then the age variable comes back again. And then, if you look at the coefficients and the magnitude of accumulation effects and also the direction of them, they're all highly statistically significant for all laps. But again, they're decreasing in their magnitude towards the final lap. So now this is where my initial hypothesis was not as much supported, because here we see the indicator for misses, simply did I miss or did I not, having opposite degree coefficient. And while the adjusted R-square is still pretty high, within R-square is pretty low, what we're seeing is that after lap 2 and 4, maybe there is something about missing at the easier position at prone shooting that might prompt the biathletes to basically ski slower, maybe disappointed in themselves. But again, this is a fraction of a minute, less than 0.02 of a minute, which is less than a second and a half, really. But it is a significant variation across all these observations. And then when you look at females only, the same effect persists. It's going in opposite directions now all of a sudden. For males, it even disappears as a whole in lap 2 and 4. So there's no change after misses in prone shooting, but in standing shooting, there are the effects of skiing faster. And maybe it is because stand-up shooting is faster to pack up after, but in theory that would be accounted for by the time spent at the shooting range, the way IBU stores their data. But essentially, 2 of my hypotheses hold up, and the key finding summary, the effect of misses on subsequent skiing time diminishes as the race goes along, and misses that significantly affect skiing time, they do so for all laps. Home biathletes are skiing faster due to possibly spectator support or knowing the track better. But again, that is not significant across the 2 genders, across all specifications. The effect of age on skiing time would increase non-linearly and is more significant for male biathletes. So age does matter in male biathlon more so than it does in female biathlon. And the overall trend of how misses affect subsequent skiing times would remain consistent over the 2 genders studied. So now, in terms of robustness, so first of all, I wanted to see, well, can we do like a subset regression, like really fast? What if we exclude all the biathletes that might be there for different motivations? Because again, I've touched in the introduction that biathlon is still a semi-professional sport, and we'll see later how that how I get this information, but just take my word for it for now. But essentially, there are professional biathletes competing on the same pitch with, border guards, police officers, students, etc. And some biathletes, they may be driven by and have the ability to train for winning and competing. Maybe they have all the conditions, whereas other biathletes from, not your typical biathlete nations, per se, would maybe compete for national pride and maybe secure some local sponsorship deals. Maybe some of the motivations that are, well studied in labor economics. So for the latter group of biathletes that might be only competing for non-monetary incentives, simply participating in the event, regardless of their competitive standing, might be their primary goal. So here, I think that there is a case that motivations might differ significantly. So what happens if we remove those biathletes? So again, this is the same specification as it is in my primary model, only where total time I'm subsetting it to the last scoring place plus 1 minute, and the fifth lap I'm truncating it down to the 1 standard deviation away, because again, in the fifth lap there is no shooting. And then there's hope that the primary goal for each race of the biathletes is, in the subset would be more or less aligned here. And indeed, what we're seeing is all of a sudden the magnitude of the coefficient for skiing time after missing at the first range, at the first prone position, it skyrockets for, something you might say, without, offending, other biathletes, but, more competitive biathletes, or ones that find themselves in a more competitive setting, after the first shooting. But then again, it slowly fades, and it fades away even more than it would in the original specification towards lap 5. What is also interesting here is that for top biathletes, being at home versus being away does not really matter in terms of how much output they exert. Age again is a non-significant variable, but this time for all biathletes. And then again, you see that the number decreases here, and this is basically the subset of biathletes that are still eligible to rank in prizes and get those monetary rewards after each individual race. Here we're seeing for females the same magnitude and the same direction of results hold, same as they do for males essentially. So we see again the high adjusted R square, and in most cases low within R square, except for it starts creeping up at the first specification. And I really think that it is due after the first shooting, there's still enough time to salvage the race by skiing faster. So that might be taken as a reference point to by biathletes to essentially try harder. But by say lap 4, after 3 sets of shooting, they already know that the race is too late to salvage, but they still statistically significantly ski slightly faster. So in terms of the gains domain visualized, let's revisit the diagram again. So what if there's a gains domain? And for that, I use a Tobit model where I left censor all the values from the median inference. So I did assume that there is no gains domain in the start, but what if biathletes know that approximately 1 miss being the mean at each of the shooting ranges, whether it be prone or standing, they might perceive 0 not as a reference point, meaning anything below 0 is worse for me, is a loss, but as a gains domain. So if I scored 1 or 0 misses, essentially, then I performed better. I outperformed my expectations, or sort of the industry expectations, if you will. So what to look for here in the Tobit model, if none of these models for each of the laps would yield any significant coefficients on the left censored number of misses, then then essentially the robustness holds up of the original model. And again, also looking for low pseudo R squares would also be important. So, and this is the specification for females only. So here it will differ across the 2 genders, and I haven't, given it much thought. So I would appreciate all the comments that you all might have, in this check. So first of all, in all lap skiing times, except for the 5th lap, where allegedly everyone is sprinting towards the finish as fast as they can, the presence of being in the gains domain actually motivates female biathletes to ski faster. So I've done better than the reference point of 1. I've had 0 misses or 1. I was at par. So I'm going to ski faster. That's actually encouraging for female biathletes to go faster. But again, take this with a grain of salt, because due to the low pseudo R square, and we can have our econometric debate later on whether or not pseudo R square is at all a great fit, but this is the only R square measure we can have in Tobit models anyways. But when we look at males, again, I think I switched pretty fast without alerting, but if you look at the first column of misses censored in the gains domain for females. When we switch to males, um, it's all over the place, and it's not statistically significant, but for any of the labs. So essentially, males just go with the same pace that they would if they were in the losses domain as opposed to the gains domain. So again, pseudo R square is very low, but it might offer some insight into how females and males perceive gains and losses, which there's an abundant literature on and might be grounds for in other research. Then looking at the race structure, race price structure breakdown through the years, we see that something that I've asked you to take my word for it. There has been an increase in the number of top finishers being compensated after each individual race. And these are not hefty compensations. As of 23-24, the winner of each individual race, and there are roughly 100, 100 competitors in each race, there would be around that would be 15,000 euros. Second place would get 7,000 euros, third place 4,000 euros, and so on, all the way to the 30th place, which gets in World Championships, the top tier level of professional biathlon, a nice sum of 200 euros, which might not even be enough to take you out of your costs spent for the race, or even that Ryanair flight that you took to get there. But it still might recoup some of the cost, and it's still a monetary incentive that is being provided. At the IBU Cup level, it's still not as good as the World Championships level, but there's still also an upward trajectory, and that is mostly developmental league, so they're not compensating those biathletes enough. And as of 23-24 season, the top finisher is only making 3,000 euros per race. So certainly there are season-long motivators. So every race, biathletes would earn season-long individual points and also the Nations Cup points, which will determine the starting grid at each of the relay races. They might even earn bonuses from the IBU and respective home federations. That data, unfortunately, has not been collected, even though it is available. And with some translation help, I could retrieve it from each of the national federations. But we do know that there is a large body of literature saying that individuals prefer immediate gratification as opposed to delayed gratification, and they're also present biased. So they're competing at each individual race, trying to win money for just that race, as opposed to seeing, well, how does me skiing faster or shooting better help me throughout the course of the season? And of course, they keep that goal in mind, certainly. The top biathletes like Martin Fourcade back in his time, or now Johannes Bö, they would keep that in mind, certainly. But, I think immediate gratification still prevails, and there's overwhelming evidence that it does. So I assume that, indeed, race-level monetary motivators would prevail over season-long motivators. And then, to get season-long compensation based on points anyways, biathletes would have to consistently perform at a very high level. It's not like in NASCAR, one win over the course of the season would get you into the playoffs. That's sort of, win to get in rule. So you have to consistently, like, say, in Formula One, if that is a better analogy, to perform consistently higher to be ranked high, in Constructor Cup points. So, and this is, something else. I've asked you to take my word for it. Then there's the occupation level groups, and it might be a bit pixely, but this is the screenshot from the extended start list that includes professional or occupational information for each biathlete. So we see that a lot of them are listed as students, and that is actually the case from, I don't have the exact percentage, but from my observations, there are very few professional biathletes. For instance, a couple of years back, there was a phenomenon of Arndt Pfeiffer from Germany, who was a police officer, basically a border security guard, who had this weapons training, and then he was also a pretty fast skier and, had good endurance. So his profession has been listed here as a police officer. But then we're looking at, the main stereotype is that biathletes don't necessarily train biathlon from a very young age, except for, very exclusive countries where biathlon is, next to religion level, like it could be in places like, Sweden, Norway, Finland, even though in Finland still cross-country skiing, you may argue, is more popular among the youth. But essentially, you either cross-country ski first, and then you learn shooting from a rifle, or you have some military weapons training and good endurance. You train yourself to be in good physical shape, and then you learn cross-country skiing. So then if we look at unsupervised mixture modeling, the Gaussian type, we could identify clusters, let the machine identify clusters of biathletes by performance. And what can we say about the intersectionability of those clusters? Meaning, essentially, if they intersect, then my performance could come from any of these clusters. So when we do that, they're the 4 clusters that R spits out if it is unsupervised. And essentially, this is how I decide to call them. So again, on the x-axis, you have the ski time in minutes. So, and on the y-axis, you have the shooting accuracy, the number of misses out of 20 per individual races. And ideally, you want to be in this lower left quadrant, if you will, of the graph. So these are better skiers than shooters, right? So again, you can have shooting performance be pretty bad, but still be classified as a better skier than shooter. So this is mostly by skiing time. Then this light green is basically this panel of balanced skiers and shooters that do both pretty well, and they don't actually go too far up. They don't miss over 50% of their shots. Then there are the better shooters and skiers, which is almost the mirror opposite of the first group. And then everyone else would be both poor shooters and slow skiers. And again, I had to truncate this at 90 because there were some biathletes from your non-traditional biathlon countries in Central Asia, let's say, that have had very slow skiing performances, and you might wonder why that might be, and that might actually be contaminating the data slightly, because what if there was an injury but they still persevered and finished the race? But then when you look at the 95% confidence region, and again, these are all the same dots, but they are being set to almost full transparency, we see that a lot of these circles intersect. So with 95% confidence, we can say that a performance landing in either of these clusters may land in some other cluster, which basically leads me to conclude that, we cannot say for sure. Of course, we can distinguish someone who's very slow and a poor shooter from someone who's a top competitor and skis fast and shoots pretty well. But everything else is cross-contaminated. And by the way, separating these 2 circles, I'm already doing when I'm doing the subset regression. So the next steps would be to basically understand the benefit of fast skiing. It is, obvious to see that clean shooting will, that performance will be, that will be obvious to your performance. But in terms of how fast you ski and how consistently you ski in light of range performance might be a bit too ambiguous. So another thing, that is the question that, I've spoken to Stefan Szymanski about, when this whole research was coming together. And his first question was, well, what is then stopping biathletes from skiing equally as fast as their competitors after a great shooting range performance? Because right now they don't seem to be doing that. So perhaps there's some sort of a loss aversion, some sort of satisficing. Perhaps they're trying to preserve pace and sort of preserve their breath so that they're not out of breath at the next shooting and they have a better chance at a shooting performance. Maybe along the race track, again, when they're receiving that precious information updating from the coaches are actually telling them that you're fine, keep to your pace, no need to do anything extra. So there would be no spillover effects from operating in the gains domain. Then why would biathletes decide to keep pace or abandon pace based on shooting performance altogether? Why is it not perceived as a separate objective of the race, as not as a connected objective? So then this would prompt me to run a few what-if scenarios, because I have data on cumulative career winnings, and that would be replicating exactly what Pope and Schweitzer did in the Is Tiger Woods loss averse paper, to basically look at how much more could have professional biathletes made in winnings from races if they were, basically skiing equally as fast as their competitors who did not miss as much. So the external validity would be to, look at basically effort substitution, which is a big thing in labor economics, and also the dynamic consistency of preferences, which is sort of the new frontier in behavioral economics. So for instance, in a simple two-task problem, do workers elicit better performance in task A? Do I try harder on task A after I don't succeed consistently in task B? And in education, for instance, to what extent would students try harder on homework assignments after getting a D plus on the midterm exam? So does it prompt them to try harder on some other grade bucket if they have performed poorly in another? In terms of policy recommendations for IBU, they have already started implementing short individual races where they would take 5 kilometers off for both women and men. And long distances are, very grueling. And while I'm not recommending that, we get rid of this exogenous time penalty addition and make everyone run extra laps, that would just take away from the competition. There is the trend for sports to be made quicker, again, with the pitch clock in baseball, with a change in overtime rules in hockey, that we want our consumers to be, pretty fast-paced. As a matter of fact, we even see, this phenomenon in social media, you may argue, that your longer videos on Instagram or YouTube or TikTok, for that matter, are nowhere to be found. And all the clips that we're seeing now are these reel types, 20 to 30 seconds bits. So maybe as humanity, we're sort of digressing to this way of perceiving information. But again, this is a trend that sports contexts are being made quicker. Biathlon should follow if the IBU wants to, have biathlon become, grow from this niche regional sport that is mostly watched in Europe, and it, not to take away from European spectators. It's very well liked and very well watched during the winter. But if it can become a more globally followed sport, perhaps, watching someone at different, stagger start parts of the race will not be as fun. So with that, I would like to take all the questions that you may have for me, and thank you so much for your attention. And of course, if it's time to leave for you now, feel free to email me or reach out to me via Twitter X. Thank you.
Perfect. Thank you very much, Georgy. There's been a few rounds of virtual applause. I'm going to add mine. That was a really, really interesting talk. To someone who knows nothing about winter sport and very little about biathlon. The stuff I've learned has been from Alex Krumer's previous talks. It was a really interesting presentation. We've got lots of time for questions and comments now. There is one comment in the chat, which is from, I guess, S. Mrozowski. I don't know, my apologies if that's not your name, but the comment is, do you think initiatives like Biathlon auf Schalke can be good for the whole sport?
Auf Schalke, meaning collaboration with Schalke FC? Or
I did a quick Google. It looks like it's some kind of world championship type thing. Biathlon auf Schalke World Team Challenge, International Biathlon Challenge every year, Christmas and New Year, since 2002 in Gelsenkirchen.
This is a commercial race at the end of the season.
Yeah. And it is in a closed stadium, and this is where they put artificial snow, and they have basically teams of the most elite athletes do like a fun relay race with only one shooting or something, right? Yes. Yeah, I'm sorry, I haven't connected the name to the event, but I've definitely seen the event on TV. So thank you for your question, and perhaps it might, but again, you may think, who's the target audience for that, for those types of events anyways. And I think it's mostly people who know biathlon. So it's European consumers who know the brand of World Championship. So it will definitely not do bad, but it will surely not invite new folks into biathlon. That would be my take. And yeah, thank you for the question.
Great. Thanks, Georgy. Okay, so in terms of hands up, we've got Arna first, then Jorge. So Arna, go ahead.
Yeah, so first of all, thanks. So I'm a biathlon fan since 1984. So I've watched in German. So I would suspect that it is a big deal. And so I have a couple of things I will try to make it short. So I think what I've missed so far in your talk, and that's a bit also going to one of those last questions you had, also Stefan said. So, and that's kind of that there is a clear trade-off between the shooting performance and how much exhausted they are. They would never, I think, run as fast as they could in each of the rounds with the shooting coming up, because that would just kind of, especially in the individual race where the penalty is a minute. In the shorter races with the penalty laps, it's maybe 20-25 seconds for the best male athletes. So that is, of course, a big penalty. And so that was what I'm a little bit missing in this discussion. So I think you should, take this into account. Then, maybe also to have more kind of the general things. Then you talk about that those athletes are amateurs. And I think that is a quite misrepresentation of what's happening. So you might find all these kind of police officers, border control officers, but that's just kind of the European way how the government subsidized the sport. At least in countries like the Scandinavian countries, in Germany and Austria, and probably also whatever, the Netherlands and I don't know, you might say how it's in Belgium and so in Eastern Europe. Those are full-time athletes. They train the whole year. They might have 2 or 3 days in the summer where they kind of put on the uniform and they do kind of a couple of pictures. So they are full-time athletes. So I think, and I've tried to figure out, because you named Arndt Pfeiffer as the German police officer who was good at shooting, and then he suddenly stumbled into skiing. He participated in some kind of junior world championship. So my guess is you're right in the sense in the story that many of them start with cross-country skiing and then they try biathlons or shooting while they do this, and that might then develop into the career. But at least of the top, 50 athletes in the world, I'm sure that no one of them by accident found out when they are 22 that they are good in biathlon. So that's one thing. And then also maybe a last question or real question with respect to your setup. So if I've got it right, so you have this variable rank after the last shooting, is that correct?
No, rank as of last lap. So
yeah.
Yeah.
But they don't know this yet, because when the first ones was on the track, so in these individual races, so roughly 95 to 100 athletes start, 30-second intervals. So if you're on at least the first quarter, you have no idea. And so also it's not always that the best athletes start at the beginning. So the best athlete of each country can choose in which of the groups he or she will start. So it might be that the best athlete will be somewhere in the whatever, third quarter or fourth quarter, because they might think that the snow conditions will be best. So again, I'm not sure that this actually, because if they can't know where their ranking is, so that might have a little bit of an influence of whether you can use that variable, if I'm not mistaken.
Yep. Well, thank you for your comments and questions. They are all definitely relevant. So I'll go in order. So the story that is missing here, and I didn't want to explicitly say this, but indeed, like golf athletes, yes, biathletes are loss averse. And I think, it has been studied, previously by Alex Krumer as well, that, if you ski, if you basically sprint to the finish, you're going to be out of breath and perhaps spend more time at shooting. You're going to be less accurate. Like that is, there's again this trade-off in the duality model sports, that you have two different objectives, and okay, you have to find trade-offs. So of course, and when updating the manuscript, I'll surely include sort of a more exact language on that. In terms of the misrepresentation in the Arndt Pfeiffer case, that they might be working like a few days over the summer, you said. Well, That might be true in like your biathlon nations like Germany, Norway, etc. So Norway is actually not the case. Norway is full 100% professional biathletes. All they do is sleep, eat, train, biathlon. In other countries that, perhaps, maybe Arne Pfeiffer was not a good example, but he is one of my childhood heroes. And, I was growing up watching him race and really, come out of nowhere to beat those titans like Bjørndalen. That was the story where, indeed he would beat uniform, too often. And it's the same idea of, say, like, if you're familiar with the UFC, there's this Kyle Dawkins guy who is he's out of the UFC now, but he used to be a full-time police officer. And there's always the question of how much they dedicate to training versus how much to their, first occupation. But the reality remains true that only the top athletes like Johannes Bö, like Martin Fourcade in his time, can fully sustain a high roller, lifestyle, or even a middle-class lifestyle, just doing biathlon. Because again, the price structures are staggered, although are all the way in the top. And if I'm, say, an athlete from some non-biathlete power nation, and I come in 30th and I get a nice 200 euros, that might not even pay for my coaching or the full time to go back. And of course, in certain countries, like that's mostly the case in Eastern Europe, where the federations would sponsor those athletes specifically. But I think that, yes, indeed, for the purposes of making it more clear, this is a good idea to have in mind, that indeed that I might be misrepresenting how the progression goes. And then in terms of the rank and them knowing this yet, I tried different specification, and I tried looking at the start time. So their start position, essentially, do they start first, second, third, 100th? And that does not have any significant effect of their performance. So what I'm thinking is, yes, the first biathlete would not have this information from the coaches going along the racetrack, but surely somewhere along the middle, like everyone, starting the second even biathlete, they will receive some information from the coaches on, you're doing good, you're up to pace, or you're 15 seconds in front of this guy. And some of them is explicitly, and I see where this criticism is coming from, because some of them in interviews, and there's a lot of qualitative data analysis that might come to this, they explicitly state that, I don't want to be told how I'm doing. Some like to be yelled at. Some are like, yeah, coach, yell at me to encourage me to ski faster during this hill climb. And you see this on TV the whole time too. Some of them, like to be encouraged, in a very soft tone. So I think that variation is something I would love to account for, but unfortunately I can't. But, altogether, yes, removing the rank of the previous lap from the specification will not do as much, to the overall model validity. But yeah, thank you very much for all your insightful comments and questions.
Great. Thanks, Arne. Thanks, Georgy. Next, we've got Hoy.
Hi. Thank you very much for the presentation. I've never seen but a couple of clips on short clips on biathlon. So my question is, I just learned about biathlon with you, so let's see if they make sense. I had a question kind of similar to what was already asked about, what is, if running is the appropriate performance measure, because one has the impression that it is important to have endurance, be fit, but I'm not sure if running is what matters. If running fast, is what matters in terms of the time elapsed during the competition. And in that sense, thinking about our sports, I don't know if we are missing competition here. The competitors. So if you are a top biathlon athlete, I don't know how you say that. And in that particular competition, are only top 10 participating in that particular race, maybe you are going to perform different and run slower because your competitors are not going to be that great. So it might matter to to control for who's competing in that particular race, and I think that shouldn't be that complicated. And the other question I have is your H and H square results, which seem to me a little bit strange. They tend to suggest that you have a U performance curve over the life cycle, instead of an inverted U, which is normally what you find when you are looking at performance in most sports, at least. And I'm not sure how to interpret that, because when you get older, you're saying that you run faster, and this is probably, at least for me, it's a bit counterintuitive of how to think about that in this sport. That would be it. Thank you.
Yeah, Jorge, thank you very much for your questions and comments. To start with at the beginning, yes. So the next step here would be to look at the exact winnings, and it's already can be estimated that yes, shooting matters a whole lot more. This is why the second side of the story is the biathletes are indeed shifting their efforts to making sure that the shooting range is spotless, especially if they are in this upper tier of the ones really competing for prizes. And I indeed I try to highlight that without explicitly saying it, but yes, indeed, maybe the whole competition is not quite there, and the structure is is designed for biathletes to accomplish their own individual goals. But even if when looking at the subset regression in robustness checks, there was an even higher magnitude in terms of how much they speed up. So yes, you can argue that when accounting for competition, skiing only matters at the second lap, and only in the top 30% of racers or so. But yeah, so in accounting for the level of competitors, I think and correct me if I'm wrong, I think the race fixed effects would eat away at this, like how many people are participating, what are their IDs. But I can explicitly look at that and sort of bring it up in the coefficient form. In terms of the strange U shape, I think it would still be the inverted U shape, because it's the increase in time as the square goes on. So if the coefficient is positive, right, then it would be a downward sloping parabola as opposed to an upward sloping. But if it indeed is, then I'm also not sure how to interpret that. I'll have to revisit my econometrics, but this is indeed not, because again, less is better. So I think there might be sort of this inverse relationship here, but I'll definitely look a lot more into this. This is definitely not the regular U shape is definitely not expected. Thank you.
Great. Thanks, Jorge. Thanks, Georgy. Alex has got his hand up.
I thank you for another paper on biathlon. So I'm not the only crazy one here. That's nice. And I like biathlon since 1986. So Arne, you have 2 years more than I have. So I have a question regarding the data. Is it you only investigate IBU Cup and World Championships, not the World Cup?
Well, because World Cup is part of the World Championships events. Yes, I have a dummy that I could have included, as I do have the dummy in Olympic races, but I have not included that explicitly, but that could be grounds for further studies. How do World Championship skiing performances or effects differ when it comes to that one event per year that there is?
No. But again, it's IBU Cup. The data is coming from IBU, not from the World Cup, right?
So in this portal, they have data on World Championship, which again, as in World Championship, it's just that they don't get National Cup points in it, and they don't get individual points, but they're racing for the same prices, and it's still set up by the IBU. So it's usually towards the end of the season, right? We're talking about the same thing.
No. Both IBU Cup and World Cup are seasonal circuits. They take place from November to March. The World Championship takes place only in February. So my question is whether you investigate only IBU Cup and World Championship, or you investigate World Cup as well, because I missed it.
Oh, I do apologize. So yes, these are all individual races for World Cup and IBU Cup for second tier and first tier. Yes, because it might be just the abbreviation that threw me off, but yes, indeed, it is the World Cup and the World Championship that usually happen towards the end of the season, each season, and all the IBU Cup races, which at the second tier they don't have such events. Yes. Thank you for clarifying that.
So sorry. So IBU Cup, I don't know, it's second tier. I don't really see why do you need it, but okay, because it's really different. There's no audience. This is second teams that compete. They're young players and so on. This may have an effect on your result. So maybe IBU Cup separately and World Cup separately. World Cup and World Championship and Olympic Games. But remove the IBU Cup, because this is really, it's like putting a Premier League and Tier 5 more or less, because these are really different.
So sorry to interject. Do you think the difference is that drastic?
Of course, because you have people from, I don't know, from Moldova that compete in IBU Cup, and then you have people from Norway that compete in World Cup. These are really different competitions.
Right, but there's still Norwegians competing at the IBU Cup. But I mean, totally, your point is well taken, and I'll look at the split, but I wouldn't think it's that much, that big of a difference like it is between Premier League and...
It could be, and this actually could explain if you, in IBU Cup, you have those either young people who are very promising or old people who are like, that's it, they just finish their career, but they still have a chance to make some money in IBU Cup, but they have no chance whatsoever in World Cup. So also the strategic considerations may differ there. Yeah, we have this entire Russian team that I don't know, Max Tsvetkov, who did really well in the IBU Cup, but had no chance in World Cup, right?
Yes, indeed.
So that's one. Second, well, individual race is a very strange race, and you have many quotes of people who say we don't like to compete in individual race. And if you are looking for surprises in the World Championships and in the Olympic Games, this is the race to look, because many athletes, they just don't like. Of course, many good athletes, they win from time to time in individual race, but it only takes place, if I'm not mistaken, 2 or 3 times a year, unlike spring competition, which is like more or less every event. And some athletes, they just say, okay, either I don't compete there or I don't really want to compete there. So I compete there because they force me to compete there, something like this. So this is something to consider. I don't know what to do about it, but whether individual race is the one that really represents, this is the question. And then in terms of the starting number, and this is to before, so you took into account only the starting number, but I think you should consider starting numbers and starting number squared, because towards the end, these are really bad athletes. Towards the beginning, this may or may not be good athletes, but towards something like 20, 30, these are the top athletes. So they are into groups, and given that they choose the number, this is strategic consideration, and this is not really random. So I think you should control for this. But I would do, and I did in my paper, it was the starting number and starting number squared. And yeah, Arne is right. Biathletes are really professional in most countries. This is just type of subsidy, you know. In France and in Germany, they work in police border, but they're really professional. Okay. At least like top 30, top 40, 50, I would say they are all professional. They may be students, but I mean, I have a student in Molde, but he's a professional football player. Yeah, that's more or less it. Thank you.
Yes, thank you very much. Yeah, I'll start from your later comment. Yes, indeed. I did acknowledge that variable of the starting number, and even after squaring it, there wasn't that much that came up, so I decided not to report it because again, you looked at sprint races there, but yes, indeed. There is evidence that they don't like to compete, and I think if we plot just a simple line graph of the number of individual races per season, it starts going down, and this is essentially why that this is sort of the feedback mechanism that is working between the biathlon union and the biathletes, that they don't want to compete in they're trying to make short individual a thing, and they've tested it at IBU Cup first, and they've implemented it a couple of times at the World Cup circuit, the top tier level. So yes, indeed, that would be almost, the relevance of this paper might be almost obsolete, in a few years if individual races are done away with. But I have in one of my additional slides, I didn't get to show that, the number of shortened individual races where that time penalty is still exogenous, but yeah, you ski a shorter distance is not sufficient to do any relevant analysis now. I think I've counted like between 30 or 40 so far in between IBU and World Championships, World Cup, sorry. And yes, indeed, that it is true that I should separate them and account for that too. And yeah, for the starting number and starting number square, this comment resurfaced. So thank you for that. And I'll have to consider that because, like you said, indeed, it's not fully random. It's random at in your group where you start. But if the group is 40th to 60th, you pick to be in that group as a starter, as a leader in World Biathlon, then you might be assigned any of the spots there from what I understand. But definitely, I'll account for that in future corrections. Thank you.
Great, thanks, Alex. Next, we have Stefan and then Raphael.
So, well done, Georgy. I thought that was a very professional and very clear presentation. So I thought very nicely done. I do have a suspicion, though, about, speaking as an American now, I do have a suspicion about biathlon, and which follows up on James' point. I don't think there really is such a sport. I think you've invented this. You've made up all the data. You and Alex and all of you. It's all, and it's a great sort of experiment that you've put together. And I think you photoshopped all these pictures. There's really nothing there. Just the great invented sport. But anyway, that's just a hypothesis. I think I need to do more testing on this. But in all seriousness, though, I do want to raise a question about the results and this issue about whether prospect theory is really the thing to focus on here. I mean, maybe it is, and I don't know. I still am, as you mentioned, I'm puzzled by why. I can see why I might be more disappointed by losses than by gains, but I'm not sure why, as a serious professional athlete, that would affect my performance. Good athletes are, impervious to wins and losses. They just try their hardest all the time. So I don't know, but maybe it is applicable. I don't know. But I thought it struck me that there's something else about this data which is really interesting, which doesn't rely on prospect theory, which is the obvious point in your regressions is that as you proceed through the laps, the effect of misses diminishes. And it seems to me, isn't that consistent with the idea that there is this substitution calculation that you have to make? The faster you ski, the higher your heart rate, the more likely it is you might miss. So that if you fall behind, Alex is shaking his head already. If you hear me, maybe it's because I don't understand this sport.
I checked it in my paper. There's zero relationship between speed and the shooting performance.
I can't really. This would account for the data. If I miss in the first round, I'm going to ski hard, because the only way of catching up now is by increasing my speed, and I have to take the risk that I might be less accurate, and maybe I'll get lucky and be accurate. But as the if I don't miss in the first round, then I'm going to go a bit slower because I can preserve resources, and then I will have some. I will be able to maintain my lead. And by the last round, that effect is gone because I'm not shooting again. I'm just racing for the finish. And lo and behold, in your data, the coefficient on the impact of misses diminishes monotonically from lap 2 to lap 5, as far as I can see. And I was looking at your tables. I was copying your tables as you did them. But
do you want me to? I can share the deck with you.
Yeah,
Yes.
But every regression table, I think, has this monotonic relationship, and surely that's the clearest piece of evidence that's come out of this paper. And you don't need prospect theory for that. You've got, regardless of what Alex says, you've got a very simple explanation about what's happening.
Okay. Yeah. Thank you. Well,
sorry. Go ahead.
Yeah. So indeed, yes, it may look like a perfect experiment, when all the 3 stars of significance light up in your regression table, and I'm really happy to go and report that. But again, if you look at the magnitude, and I fully agree to that, I think I've mentioned it in passing when I was presenting, is that while they may be statistically significant in terms of the effect on skiing, they're still very, very low in terms of the actual number of seconds added or subtracted per lap. So yes, you do try harder, like it's almost half a minute. It's like 0.43 minutes, which is, close to like 25 seconds. If I'm doing like math on the fly. So yes, in the top biathletes, it does matter. The ones that do perceive themselves as a professional athletes, as Arnie as have mentioned, there is indeed that effect that if you look at just the top competitors in the distribution, yes, they will be much more risking it after the first shooting, to make up for it by their skiing time than they would after the second and the third. So yes, that gradient, I think, indeed, is something that I should elaborate more on, and thank you for pointing that out. That is the cleanest piece of evidence. It might even be tied to like a reverse goal gradient hypothesis if there's another attempt to resurrect that. But that might be the avenue I take it. So yeah, thank you for your comment and question.
Excuse me. Thank you, Stefan. Then Raphael.
Yeah, hi, nice talk. Thank you very much. I have a question and a comment. So first, if I'm not mistaken, in the paper by Pope and Schweitzer, so in their golf paper, they are using dummy variables. So 1 stroke below par, 2 strokes below par, and so on. And they also have some nuanced prediction for each of them. And maybe this could something you could look as well, instead of using your continuous measure of the number of misses. So that would be the comment. And second, your analysis is on lap level, right? So you basically find that athletes ski faster after they miss, right? But what are the implications of this behavior regarding the rank at the end of the race, which is basically the main objective that counts, right? So is this behavior beneficial or is it detrimental? So in golf, it's clear, right? So less strokes are actually beneficial, but in your setting, it's not that clear. Thank you.
Yeah, totally. I have tried looking at it, in dummy, and frankly, when I did this as a categorical variable as opposed to a continuous numerical variable, it did not give the results that I think were telling a compelling story. Like the direction of the effects were both ways. So I'm not sure why that was happening, if I screwed up the coding someplace, but yes, indeed, that's how Pope and Schweitzer do it. And this was still, to this day, one of my, one of my top 10 maybe encounters when I got to talk to Devin Pope after one of the speaker series events about this paper at length, and he was basically saying that this was what was available at the time, and this is why they did it in sort of the fashion that they did it in terms of like a categorical variable. But I'm not sure if he even tried it, in some unpublished specifications it continues. But yes, of course, I fully understand, how just looking at the exact number as dummies would be beneficial. And then in terms of the behavior being beneficial towards like the goal, the outcome of the full race, there is like another avenue I can take this. So I do acknowledge this is very important. I was just trying again because I'm time limited in this series also, and then it wouldn't be nice to write like a whole book on all the sides of the effects, but that could be like another paper on looking at, well, yes, it matters on the subsequent lap. So again, what I was trying to elicit is from not the objective of the whole race, but how do individuals respond to failing in task A by performing harder in task B right away? Not necessarily do they accomplish like a season-long or a year-long goal, but this is something I'm feeling very motivated to research now that you mentioned. So thanks for bringing it up. Thank you, Raphael.
Great, thanks, Raphael. One last question, Anna.
Yeah, so due to some of the other comments, I kind of thought a little bit about this. So there's also, of course, one aspect that we have not addressed, and I've not heard you saying this, and that's actually the shooting range time. That's of course also a variable that the athletes can influence. And so I was wondering, and this is now just a very quick thought of mine, whether it's not the shooting, the shooting or the misses of that influence the next round running time, but the lap time. So the running plus the range time plus the potential penalty, maybe that's explaining whether they decide to run faster. Because they have probably their kind of reference point of, okay, if I'm this range and now I'm really behind and now I try to catch up. And so Alex, of course, I will not question your results you did, but all conventional wisdom you hear from coaches and athletes in the media, they believe in this trade-off between running and the exhaustion and then the accuracy of the shooting. So at least in the media. So
yeah, you're right. What I did is before the first bout of shooting, no relationship between skiing time and the performance. So
yeah, Arnie, thank you. Follow-up comment. That is indeed something I tried to look at. So I was recording variables, but then in a lot of these races, and I think it goes back to who's the official tracker, like who's the official scorer for each individual race. So like something scored at Kontiolahti, Finland, will give you a very different number for the range time as it would in like Hochfilzen, Austria. Because like somewhere they include the misses in it, somewhere they don't, somewhere they include the time where they unpack the rifle, somewhere they count range time as the moment they enter the stadium, the grandstand area, till the moment they exit. So there's this new data that's available, which is like point by point on the same portal, which is dynamic, and I'm figuring out how to scrape. And it only has started, I think, a few years back. So it doesn't go as far back as like your PDF 2001, 2002 reports. But that has intervals basically pretty continuously. So it goes as far as you can build a very nice, smooth function of the progression of the total time. Yeah, that is ground for further research, I think. And for that, I think we'll have to wait a couple more seasons until like a good inference can be done of that. But this is something I'm already interested in pursuing. So yeah, that is your idea totally. And I would love to, if you want, we can exchange some emails on where this could be taken. But thank you for that.
Great. We've reached time, so thank you for a really interesting talk and really good provoking discussion as well. It's been a great first week back. We return again next week, next Friday. We're going to have Lars Vischer from Munster presenting on coach characteristics and their impact on substitution decisions. So I look forward to seeing you all again next week, and I wish you all a fantastic weekend in the meantime. Cheers, everyone.
Thank you all. Thank you. Bye.
Bye-bye.